I apologize, your time is up. Something about the sound is a little strange. So, colored pens up. So today we have 2 review questions and an FCAT question. Actually, they're all FCAT questions, but 2 are directly related to our most recent lesson. And 1 is related to a topic that we've talked a little bit about throughout this year, but nothing formal. So let's start with number 1. What did we get? 1, 2 competent people. 3, 4 competent people. Good. We'll start with Adriana, Chelsea, David, George, and then Tristan. What'd you get? No answer at all? Okay.
About 16 times.
16. About 17. 0.1, okay. Any other answers? DeAndre, Nolly?
Yeah, I got
0.1. 3. Okay, so we got a lot of different answers floating around, but the one that was agreed upon by a couple people was 17. Any other answers? Natalie, what'd you get? 16. What'd you get, Amon? You got 16 as well. The correct answer is 19. So of course that was not necessarily easy, but we'll talk about number 1 in a moment. Let's talk about the review questions. Number 2, how many deliveries do you need to make to earn at least $30 in tips? Oh, now we got a little more confidence. We'll start with Essence, Savannah, and then Kiara. What'd you get? Okay. Well, you guys can give yourselves half, but it's 12 or more. Or if you wrote that x is greater than or equal to 12,
Yes.
something like this, then I would accept that as well. But we're talking about inequalities and we're talking about money possibilities. And so 12 is not the only possibility, because if this person makes 13 deliveries, they will also achieve their goal. And if they make 14 deliveries, they will also achieve their goal. The key phrase is this right here. This person is not trying to make exactly $30, they're trying to make at least $30. So if they make more than $30, that's a good thing. So that changes the situation. So if you wrote simply 12, you can give yourself half. Number 3, what amounts could you earn to be able to pay your parents back? Start with Cameron, Nolly, and then Fancy. What'd you get?
$37 or more.
Okay. It's a weird way of saying it. Why don't you say it one more time?
Well, it's 37 or more, but I wrote x is less than, greater than, 37.
Okay. You can't really say less than and greater than.
Wait, I didn't say that.
I know you didn't. That's why I'm asking you to say it again.
I'm going to say x is less than or equal to 37.
Okay, so now just so you know, the way you said it in words and the way you said it in math are conflicting. You said 37 or more, and then in math you said 37 or less. So you need to figure out which one you meant. What'd you get?
37.
37. So the correct answer is $37 or more. And again, if you put it in math terms, you could have written n is greater than or equal to 37. That's the way you say 37 or more. So I'll take a couple of quick questions on numbers 2 and 3, and then I'm going to spend more time on number 1. Dave.
For number 3, what were you supposed to divide that to the weekend, Saturday, and Sunday? You see it? Is that just for this weekend? And 2 days in the week. So
Okay, that's a fair point. But all I'm looking for is how much do you need to make at the job. Doesn't really matter how long the job takes. For example, you had, for this homework assignment that was due today, you actually had 5 days. Should I take your grade and divide it by 5 and give you 5 different grades for it? No, we get 1 grade even though it was over a 5-day period, right? So you make a valid point. I like what you're thinking. Your thought process is very good. You're thinking, hey, but it's 2 days, wouldn't I divide it by 2? So in your terms, we would say, well, then you take 37, divide by 2, so that's $18.50 each day or more. That would be a good way. So is that how you wrote it, or? So I will accept your answer because your thought process and the way you explained it makes it correct. You understand what I'm saying? Now, unfortunately, on the FCAT, or a formal test, you don't get a chance to verbally explain your thinking, and so if that was your answer and that's what they were looking for, you would get it wrong. But since here you do have a chance for that dialogue, I like what you did. Good, so you all divided by 2?
Yes.
Okay, so same thing goes for you guys then. Good. And I really like the thought process that you went through. That's really good. Other comments or questions for numbers 2 or 3?
Can you go over number 3?
Sure. So let's start with number 3. Give me a quiet thumbs up if you got it correct. Good. Alexis, did you write an inequality, or did you just try to think your way through it, or what did you do? Oh, what'd you write? Okay, but that's a solution to an inequality. Did you write an inequality to start with? Okay. So how'd you figure it out? So you use magic? Okay, well, so when you say I just got it, that's, that's like from Harry Potter. You just got it. That's magic. Okay, so Alexis used magic, so since she's the only one who's equipped, well, I also am equipped with magic, but she and I are the only ones who are magically powered inclined, then I need a more human way of doing it. Because she and I are mutants. I'm not kidding, bro. Anyway, Chelsea, what did you write?
I wrote 95 minus 38 plus 20 plus 38 plus 1 in parentheses.
Okay, so 95 minus 38 plus 20.
And then I added 38 plus 1
Mm-hmm.
and I subtracted 95
Okay, so did you at any point write something like this?
No, I wrote
You wrote 1850 or more? Okay. Okay, good. So you logicked your way through it. Good. Very good. So in the context of what we've been studying, and again, we had Thanksgiving break, so it's been almost a week since we worked together. What we're looking for is to write an inequality. You owe your parents $95. So remember the things that I always ask you to find? So what's the first thing I always ask you to find in a real world scenario? Total. So there it is right there. You owe your parents this total amount of money of $95. So, $95. And we already have $38 and $20. So I like the way Chelsea explained it. She put that in parentheses because she knows that those two go together. And that's $58 we have already. And we have a job scheduled, but we don't know how much we're going to make. But that number plus the 58 must come out to more than or equal to $95 for us to have enough money to pay our parents back. So that's where the 37 comes from. This. So again, I don't care if you logicked your way through it or used magic or whatever you did. But in the context, in the circumstance of what we're studying inequalities, this is what I was looking for. Okay? Yes. Okay?
Okay, you know how we're like last week we did multiplication
Mm-hmm.
and division?
Mm-hmm.
So I thought it probably was going to be
Well, here's the thing, and he brings up a good point, is that, okay, so the most recent idea that we talked about was multiplication and division inequalities. So it would make sense that my warm-up for the next day would have to do with that. But here's where you have to become an independent thinker. And we're going to practice this more and more after the holidays as we get closer and closer to FCAT season and testing season. But you have to become an independent thinker. Your job is not just to take what I teach you and, like a robot, just spit it out to me exactly the way I taught it to you and try to match up the scenarios. I try to give you tips on how to be successful in different scenarios, but your job is to take all of that and become an independent thinker. And so you cannot rely on me to tell you whether this is a multiplication, division, addition, or subtraction. You have to look for words. You have to look for phrases. You have to look for language that indicates what you're going to do. This one does not have a lot of words or phrases in it that tells you what you're going to do. But you have to think about the scenario. Both of these questions start out with you. So put yourself in the situation. If you owed your parents $95 and you already had $58, why go through all this trouble of trying to figure out what operation you have to do? Just think about the scenario and think about what would you have to do to be successful. Okay? So now I want to talk about number 1, and we can consider this a mini lesson. Does anyone know what major math concept or major math, it's actually a branch of mathematics, that this question comes from? Got 4 people who have an idea? DeAndre?
I think it's probability.
You thought correctly. It is probability. Give me a thumbs up if you've ever played the game of skunk in my classroom.
Oh, wait.
Okay? So if you don't remember, that's okay. I would have thought you'd remember something like that, but I think there was days when there was some people out on a trip or something. So you can put your thumbs down. So the game of skunk, and we will play it again in the future, especially as we get close to holiday season, but the game revolves around the understanding of probability. Give me a thumbs up if you've ever played, let's see, Monopoly. Thumbs up if you've ever played Monopoly. Good, almost everybody. Put your thumbs down. What determines how many times you go around the board? Like what determines how many spaces to move your game piece? Adriana? Dice. Give me a thumbs up if you can picture dice in your head. Good, put your thumbs down. This is the quintessential, the most common example of probability is a pair of dice. It's random. You roll the dice. That's the whole point of it. That no one knows what's going to come up. But you can predict what will come up more than others. And that's what makes Skunk so much fun, is that your job is actually to figure out how to play the game better, not so that you guarantee yourself to win, but so that you have a better chance of winning. Well, this question is a different take on probability. It's not using dice, it's using cards. But it all revolves around the same idea. And it's all related to an idea that you do almost every day in my class on these. After I give you one of these yellow slips and you grade your homework, what's the next thing you do? It was a question to be answered. After you get this slip and then you grade your homework, because I put the answers up, what's the next thing you do? Savannah? Well, there's something else you do before that. After you grade your homework, meaning you mark your questions correct or incorrect, what do you do on the slip? Go ahead.
You calculate your percentage.
Before you do the percentage, there's something else you do. What do you do, Nolly? There's something else we need as well. So we've got 3 parts of it. 2 out of the 3 parts. Tatiana? The number, what goes in the denominator?
All the numbers, like the questions, all the questions.
Okay. Good. Catalina?
The on top of the number the number you got correct over all the questions.
Okay. So that's basically the idea. It's the same idea here. The top of the fraction is the number you get correct. The bottom is the total possible. The top of the fraction is the number correct. The bottom is the total possible. It's the same thing here. The bottom is the total possible. What's the total possible? Now you're going to actually have to look and try and interpret. We got 6 light bulbs. What do you think, Natalie? Okay, what do you think, Nancy?
8.
Okay, so one person thinks 50 and one person thinks 8. Any other possibilities out there? Chelsea? You're going to say 50, Savannah?
8.
So we're pretty divided, so let's do a survey. Give me a thumbs up if you think the total possible is 50. Okay, put your thumbs down. Give me a thumbs up if you think the total possible is 8. Adriana, you didn't indicate either way. Essence, you didn't indicate either way. Okay, so the total possible is 8. Because there's 8 cards. These are the possibilities. There are 8 cards. So the total possible is 8. I understand why you said 50. But this has nothing to do with it. This is how many times you're going to do an experiment. But the experiment is based on what's shown there. There are 8 possibilities. Now, instead of the top being the number we get correct, the top is this. The numbers greater than 5. So instead of it being the number we get correct, it's the number greater than 5. So, which ones are greater than 5? Adriana? 6, 8, and 7. So 6 is greater than 5, 8 is greater than 5, and 7 is greater than 5. Any other ones that we missed? Tristan?
I think about
Okay. Well, this is an inequality. Greater than. You're thinking of greater than or equal to. 5 is equal to, but not greater than. So there are 3 possibilities out of the 8. 3 out of 8. That's the probability. 3 out of 8. I only see a few people writing things down. I'm not sure why, because no one got the question right that I'm aware of. So the probability is 3 out of 8 of getting a number greater than 5. So now we have something to go with. Next time we play skunk, there's a way to improve your odds of winning by understanding the probability behind the game. It's a different scenario, but if you can figure it out, you can improve your chances dramatically. You can in any card game or dice game. Now, where does the 50 come in? So watch this. On these yellow slips, Savannah already told us, after we make the fraction, what do we do next on the yellow slips? After we make the fraction, Stephen? Good, and what does that get us? Okay, does it? Let's find out. Everyone pick up your calculator, and we're going to do 3 divided by 8. 3 divided by 8. What'd we get? Natalie? Yeah, you get 0.375. Is that a percent? What form is that in? That's decimal. So how do we get it to the percent that he was talking about? Angela? Yeah, move the decimal 2 to the right and then round if you need to. 1, 2. So what percent would this really be if we rounded it? Amani? 38%. So we could say that there is a 38%, and listen to this word, there is a 38% chance of choosing one of these cards. 38% chance. So now, we're still not to the 50, but I have a different question. What does this symbol mean? What does that symbol mean? 5 people who think they know. 6, 7, 8 people. Cameron?
Out of 100.
That is exactly what it means. It means out of 100. And it's okay if you did or did not know that, but give me a thumbs up if you already knew that. Good. Put your thumbs down. For those of you who didn't know that, watch this. And even if you did know that, watch this. I'm going to take this symbol and I'm going to take the pieces of it. Watch what happens. Oops. What does that look like? What does that look like? Stephen? It looks like a lot of different things, but yeah, it looks like 100. 1, 0, 0. So when you say 38%, what you're saying is 38 out of 100. This is a short way of saying this. This is a short way of saying 38 out of 100. This is saying the same thing as this. So here's the part. That's the key. If I played this game of shuffling the cards and picking a card, if I did it 100 times, how many times would I pick a 6, 7, or 8? If I played the game 100 times, how many times would I get a 6, 7, or 8? David? 76? Okay. Well, where'd you get the 76 from?
Well, because I asked this 50 times, the way you showed it, it was 38%.
Right, it was 38%, which is 38 out of 100. Well, that was a good thought, but you went too far. You made it harder than it really is. 38 out of 100. If I play the game 100 times, how many times will I get a 6, 7, or 8? Catalina? 38 times. If there's a 38% chance of something happening, and I play it 100 times, then 38 times it's going to happen. That's what percent means. So now, how can we get the 19? Chelsea, you see it now? How come I divide it in half? Good. So she sees that 100 is double the 50. So if she cuts this in half, she'll get the 50, which means we have to do what to the numerator? Cut that in half too. 38 divided by 2 is 19. So once you have a probability in percent form, you have a lot of different options that you can do to get your probability for the scenario. Okay? So I know that was a lot to take in. Hopefully you wrote some things down to help yourself. Because here's the key. If I took this same exact question and I changed the numbers on the cards, I changed the characters' names, and then instead of saying number greater than 5, I said a number less than 3, you should be able to tell me the answer. Because it's the same exact question, just changing the information slightly. Okay? So, I used this question as a mini lesson on probability. Comments, questions, quickly. Fancy and then Tristan.
So when it was like warm up time, I was trying to ask you, do we put like is the final answer going to be in a percentage or a decimal? Or
It depends on the question. The question says, how many times? It's asking how many times would it happen. So this would happen 19 times. If it asked you what would the probability be, then you could write 38%. Or you could write 3/8. These are equivalent. Okay? Tristan.
So I still don't get one.
Okay. Well, I don't expect you to be an expert right now. One of the issues that some of you face is that you think I'm supposed to show you one time and you're supposed to be an expert because you're a very smart person. But that's not the way the world works.
Yeah.
So, okay, so you got to give it some time. We did one question. We're going to do more. Okay? Good. So, way behind schedule. That's not your fault. That's mine, but I'm going to. So today we're going to venture into multi-step inequalities. And I want to retrace our steps, and I'd like everyone to look back here for a moment. And even though this is a map for Algebra 1 Honors, it applies to you guys because you guys are basically doing a small part of Algebra 1 Honors. So here's what we did. We started out with one-step equations. We spent a couple of days on this to get very good at it. From there, we built the next step. We went to two-step equations. This was reliant on this. We needed this skill to work here. From here, we went to multi-step equations, where we incorporated combining like terms and distributive properties. And then you use all the skills from here to be successful here. So these three posters was really a building process for you guys over a course of about 2 to 3 weeks. So we ended up here. And we were pretty good at this. I think we're experts at two-step equations. But we're pretty good at this. And then I shifted gears a little bit. Then I switched to inequalities. So basically we went back to here, except instead of an equal sign, it was a different symbol. And then we spent a couple of days on that. And then today we're now back to here. We're going to now add here. We're basically doing both of these together. So it's a building process. So we're doing multi-step inequalities. We're building from what we learned before. We already know what to do. We know everything. I'm not teaching you anything new. It's just a matter of putting it all together the right way. So to solve an inequality, you've learned over the last few lessons that you do the same thing you would do when you solve equations. But this one new rule is critical. When you're solving an inequality, if at any point you multiply or divide both sides by a negative number, you flip the inequality symbol. Now, I gave you this same statement last time, but there were 2 words that I had accidentally omitted, and it was these 2 words right here. Both sides. This rule only applies when you're doing a transformation, and that's when we multiply both sides or divide both sides. It's not when you sometimes multiply one side, it only applies when you do both sides. So, you may not know what I'm talking about yet. That's fine. We're going to do this together. But this is the only semi-new piece of information here. And again, we did this last time to a less complex degree. Before we start solving inequalities, we want to make sure we understand what a solution is. So we're going to start out by exploring the idea of a solution again. So, example 1, we're going to do 2 of these. Tell whether a number is a solution to an inequality. So, how do we figure out if negative 20 is a solution to the inequality? You already know how to do it. You don't need me. What do? Okay, let me say it differently. You're supposed to know how to do it. I've got 5 people who seem to know how to do it. Now I've got 8 people who seem to know how to do it. Tatiana and then Steven. Tatiana, what do we do?
Replace the x with -2.
Okay, what would you do? Same thing? Yeah, I love the way she said it. We replace the x with the negative 20 and simplify. But here's the key part that she didn't say because she didn't realize how far we were going to go. After you do that, then you have to see if it's a true statement. So we'll get to that in a moment. So we're going to rewrite this whole thing, but with a negative 20 in place of the x. So here's what it's going to look like. And now we're going to put a negative 20 right there. Now I have to see if the left side, this whole thing, is this whole thing less than 9. I'm sorry, let me say that again. This whole thing is greater than 9. So how do I figure out the value of that whole thing? How do I figure out the value of that? We've got a bunch of people who know. Natalie? Good. We follow the order of operations and we simplify the whole expression. This has to be done first. Negative 20 divided by negative 4. What do we get when we do negative 20 divided by negative 4? Tristan? Yeah, we get 5. So this is a 5 plus 5. And the statement is 5 plus 5 is greater than 9. Well, what's the value of 5 plus 5? Come on. 10. So now the question is 10 greater than 9? We have to say if that's a true statement or a false statement. Give me a quiet thumbs up if you think that is a true statement. Good, put your thumbs down. Excellent. That is a true statement because 10 is greater than 9. I could prove it on a number line. If this is 9, 10 would be right here, and anything to the right is a bigger number. So clearly 10 is bigger than 9. Because that's a true statement, what that tells us is that this is a solution to the inequality. The answer is yes, it is a solution. If this came out to a false statement, then this is not a solution. And that's how inequalities work. It either makes a true statement or a false statement. Yes, Tristan. You can say either way. Any other comments or questions about how we did this? Okay? How do we figure out if this one is a solution? This looks totally different. I want to know, is negative 5 a solution to that? How do I figure that out? Catalina?
You like substitute -5 for x.
Very good. You said that beautifully. Take the negative 5 and put it in place of that and in place of that. And then the key is, again, to determine whether or not it's a true statement. So here's what we have. 7 times negative 5 minus 6. Is that value going to be less than or equal to 4 times negative 5 plus 9? So we have to start out by simplifying this. How do I simplify that? You guys are just doing it, or oh, you're just doing it? Okay, that's fine. So what's the first thing we do?
Well, the first thing we would do is replace x with 5, and then you do 7 times 5 is 6, and 4 times
Well, it's not 5, it was negative 5.
negative 5. So 7 times negative 5 and 4x.
Well, I'm not doing the other side. I've focused. Look at what I've done on the screen.
7 times negative 5.
Good, and what do we get?
You get negative 35.
Excellent. So here's where we're at. Negative 35 minus 6. What do we get from that? Essence? Ah, that magic phrase that came up on a quiz. Keep, change, change. Some of you don't even need to do it. Some of you do. It doesn't really matter. It's all about success. And so what do we get as a result of doing that? Stephen? Very good. We get negative 41. So the value of the left side is negative 41. Now we have this right side, and I want to know, is this greater than or equal to negative 41? So what's the first thing I do on the right-hand side? Savannah?
You first do 4 times -5.
Good. And what do we get?
-20.
Excellent. Negative 20 plus 9. You had a question?
Yeah. When I did it, I didn't do QTs. I
And-
just did -30 -6.
That's fine. Did you get the correct value? So then it doesn't matter how you do it.
Will it always come? Will it always work with that?
Well, when you say you did negative 35 minus 6, you use the calculator? Okay. If you punch it in the calculator correctly, then it will work. My point is, I don't think you need to. I think it's a waste of time. But that's fine. It's your choice. It's no big deal. Okay, so now we're here. Negative 20 plus 9, what is that value? Alexis?
-11.
That's negative 11. Very good. So here is the statement that we end up with. The question is that a true statement or a false statement? Give me a quiet thumbs up if you think that is a true statement. Interesting. Okay, put your thumbs down. Well, unfortunately, some of you don't know your number line well enough because that is a true statement. Negative 49, negative 41 is much smaller than negative 11. That's a true statement. This is a number line. If that's 0 and that's negative 11, where would the negative 41 be?
There.
Way over here somewhere. So you have to have a picture of a number line readily available in your head to put things on so that you can picture it, or you need to draw it. But one way or another, you have to know that this is a true statement, which means that yes, negative 5 is a solution to the inequality. Comments or questions before we move on to the real work of the day? Good, we're doing well so far. So now we know how to check and see if our solutions are correct. But now we need to solve some complicated inequalities. So you don't have to write the instructions. I just like to show you what the instructions are going to look like in the book or in the workbook or whatever on the test. One thing I've been emphasizing to you is that solving an inequality is the same thing as solving an equation, with the exception of that new rule that you have to have as a banner running through your mind. If you multiply or divide both sides by a negative number, you flip the inequality symbol. So we'll check that at the end, and we'll make sure that we change our answer if we need to. But everything else is the same as what you've already done. So in other words, solving this is going to be the same as solving this. It's going to be the same process. So, let's see what we remember. What's the first thing we should do? First thing, everybody should have their hands up, but or a lot of people should have their hands up. Chelsea? Yeah, you have to distribute because you were taught that you simplify and then solve. Simplify, then solve. So you have to distribute before you do anything else. So we're not even solving the inequality yet. We're just simplifying the inequality. So what's negative 3 times 2? What do we get as a result of that? Kiara? Negative 6. Here's the hard part. Negative 3 times that. What do we get as a result of that? George? Very good. Negative times negative is positive. 3 times x is 3x. So we simplified the left. We've got the inequality symbol. There's nothing to simplify on the right. Now we're ready to solve. You might want to make one adjustment. If you're like me and you like things to look a little bit nicer, you might want to take the 3x and switch it with the -6 so that it looks a little more friendly. But it's your choice. You could do this or leave it the same way. It will not make a difference in the end. So now we're ready to solve. So now we draw our t. And what's the first step in solving? What's the first step in solving this? What do you think, Natalie? Okay, Stephen, what do you think? Okay. Tristan, what do you think? Good. So which one is it? So you agree with what Natalie and Stephen said. Good. And you said it a little bit differently, and I like that. So we're finding the x term with the smaller coefficient, and that's this one. And we subtract it, which is the inverse, from both sides. This will disappear, and now we work down. 3x minus 2x is 1x. Minus 6 is less than -9. Does anyone have any questions about how we got there? Okay, what do we do next? What's next? Angela? Okay, what were you going to say, Fancy?
I was gonna say the same.
Same thing? Okay, I would agree with that. Add 6 to both sides. This will cancel out. And we're left with 1x, but we all know that 1x is the same thing as x. So really we're left with x is less than what? What's the final result? Tatiana? You agree? Yeah, it's -3. Very good. But before we circle our answer and pat ourselves on the back, we have to check and make sure that we have met this rule. So we have to check our work. Did we multiply or divide by a negative number at any point on both sides? So what I mean by is this. I am looking, or we are looking here. Did we multiply or divide both sides by a negative number? Did we multiply or divide both sides by a negative number?
No.
When I say both sides, I'm talking about when we do one of these. So in either of those steps, did we multiply or divide by a negative number? No. We subtracted and we added, but we did not multiply or divide by a negative number. So we do not flip the symbol, which means that our solution is x is less than -3. So now we can proudly and happily circle. And then we need to graph, and I'm going to have to shrink my graph down a little bit. And so we do the same thing we've done for a few days now. Put that number somewhere in the middle. That's a -2, that's a -1, that's a 0, that's a 1, that's a -4, that's a -5. And now we need to put a 0 on top of one of those, on top of the -3. What type of, did I say 0 or circle? Circle. Sorry. Circle. We need to put a circle on top of the -3. Which type of circle do we need? Which type of circle do we need? We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We got a lot of people who know. Cameron? An open circle. Do you agree, Nolly?
Yes.
Yeah, it's going to be an open circle because there's no bar here. So we're going to put an open circle right here. But now we need to shade. Do we shade to the left or do we shade to the right? So I want you to point your arm in the direction that you think we're going to shade.
It's the right.
Okay, good. You guys are right. We're going to shade this way because the arrow is pointing that way when the X is on the left. So now use your pencil or your colored pen and fill in from here over, and then draw an arrow on the end to indicate that it goes on and on forever. Does anyone have any questions on how we got from here to here, here to here, solving, graphing? Any questions? Catalina?
Why did you add the 6,009?
No, when you are trying to solve an equation or inequality, you're trying to get the x by itself. So you always start on the side that has the x. Okay, is it coming back to you now? Okay, good. Other questions or comments? Good. Well, that was only one, so let's see some more and see how we're doing. Part B. So again, we're going to solve. It's a slightly more complex inequality. But again, you've done questions like this, equations like this, so it's just a matter of pulling those same skills. What's the first step in solving this one? 1, 2, 3, 4. Stephen, Tristan, and Essence. Stephen, what do you think it is? Okay, but after that. Okay. What were you going to say? Okay. Essence? Okay, so we do have a disagreement. Some people say add 9 on both sides after I draw my T, of course. And some people say multiply both sides by -3. And I'll be honest with you, most of my students in my classes say multiply by -3. So which do you think? Do you think we add 9 or multiply by -3? Give me a thumbs up if you think we should add 9. Okay? Give me a thumbs up if you think we should multiply by -3. Well, some of you didn't put your thumb up at all, so you actually had to put your thumb up for one. Okay. So, in this case, we add 9. Because when we solve an equation or an inequality, we go in reverse order of operations. So addition and subtraction always gets taken care of first. Before we do that, just to make sure we're clear, what if I asked you to solve this? What would the first step there be? See, now I got a lot of people who think they know. Catalina, what's the first step on the green one? Give me a thumbs up if you agree. Add 10 to both sides. Okay, so put your thumbs down. So most of you are able to see that. But now all of a sudden I throw this in, and all of a sudden that becomes hard to see. But it's the same situation. So yes, we add 9 to both sides over here. Yes, we add 10 to both sides here. We always take care of addition and subtraction first. So, add 9 to both sides. Work our way down. This disappears, and we're left with x over -3 is less than what? I had a lot of people struggle with this in my last class. Nolly? Did I scare you because I said people struggled?
No, I don't know why I raised my hand.
Neither do I. Oh, we could do that too, but I'm just looking for -7 plus 9. What's -7?
Oh, it's 2.
Thank you very much. Very good. It's 2. Very good. So do you also know what's going to happen next? Go ahead. Go ahead.
I think you multiply by -3.
Good. So yeah, now we have to get rid of this, so we multiply both sides by -3. That's how we get rid of this denominator here, and you learned that quite a while ago. This cancels this, and we're left with our x. and is less than negative 6. But now we have to check the rule. Did we, at any point, multiply or divide both sides by a negative?
Yes.
So let's check the steps that I took. Here's one step, and here is the other step. Did I, at any point, multiply or divide by a negative number?
Yes.
Yeah, we did. Which means we have to flip that symbol to the other direction. So our true answer is x is greater than negative 6. Any questions or comments on how we did that? Good. I'm a little bit behind schedule still. We're supposed to graph this. I'm just going to skip over that one step for the moment. You're going to graph the next two on checkpoint, but I'm just skipping it for now. Yes, Annie?
For that, we only have to say yes or no for the ones that have the variable, like, you know what the variable is.
Okay, so in these questions, we were checking the answers. So we checked, we're trying to say, is this a solution to that? It's a yes or no question. Here, I have to find the answer. So we're solving it, and this is the solution. Is that what you were asking?
Yeah.
Okay, is it clear now? Good. So let's see how we do on our own. Checkpoint number 1. You got 2 questions, you got 3 minutes. Solve and graph. What do you need to do? I apologize again, the sound wasn't working, but your time is up. So colored pens up. Let's see how we're doing. Part A, what'd you get? Good, we got a lot of common people. Kiara, Annie, and then Nolly. What'd you get, Kiara? Okay, what'd you get, Annie?
4 is greater than or equal to x.
So we have a disagreement, Nolly. So we have actually 3 different answers, even though they sounded similar, they were all different. Essence and then Angela.
4 is less than or equal to
Okay.
x is greater
Okay, so here is the solution and the graph. X is greater than or equal to 4, but there is another way I'll accept your answer, but then I will clarify also that if you put 4 is less than or equal to x, I will accept it. However, you were taught that when you're done, we want the x on the left-hand side, so that you were supposed to flip the entire inequality. Everything was supposed to flip around the other way. So I will accept either one, but the best answer is the one I circled right here. Okay, Savannah?
So if we did it the 4, do we say that the arrow has to be moving
The graph?
Yeah.
The graph is still the same. No matter which answer you provide, whether this is your answer or this is your answer, this is the only graph that's possible. Because the trick that Ms. Cooper taught and that I am reinforcing about following this arrow to show you which way to shade only works if the x is on the left-hand side. If the x is on the right, then that doesn't work. So that's another good reason to switch the whole thing around. So if you got this correct and you got this wrong, you can give yourself half. That's fine. All right, part B. In the interest of time, I'm going to reveal the solution. X is less than 8. No, part B was a little bit easier than part A. So, comments, questions, Essence, and then Tristan. Did you multiply or divide by a negative number? Okay. 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 Yeah, we only flip the symbol if we multiply or divide by a negative number. In this case, we multiplied by a negative 4 at some point, so we had to flip the symbol. In this case, we do not multiply or divide by a negative number at all, so the symbol stays the same. All right, so now we're going to do real-world application of this. I'm going to put up a question that describes a real-world scenario. Read the question. You do not have to copy it, but you have to read it. So go ahead and read example 3. And we are going to work on it, so of course you have to write example 3 as well. Write the words, example 3. So it continues to come back to the outline of information that I've been asking you to find since the beginning of school. What is one of the pieces of information that I asked you to find when solving a real-world scenario? Only 3 people? No? Really? Really? Stephen? The total. So we'll start with the total. Very good. What's another piece of information that I've asked you to pull out of a real-world scenario? Annie?
Flat fee.
A flat fee or a flat number. But now I want to pause for a minute because I also introduced other words that mean the same thing. What was another word for total that I introduced along the way?
Start.
You got it confused, but that's one of the words. You just used it in the wrong place. Angela?
End.
Yeah, the total is the end. And what about the flat fee or the flat number, Cameron?
I don't know. Start.
The start, yes. Cameron, I called on you on purpose because I knew you knew. So this is also called the start. So we got the total, we got the flat fee or the flat number, which is also called the end and the start. What else is a piece of information you've been asked to pull out? Chelsea? What's missing? Very good. And there's one other piece of information. Catalina?
Rate.
The rate. So let's pick out these pieces of information from the text. Now, of course, you are working with me on all of this. So what's the total in this case, or the end? What's the total or the end? DeAndre?
10,076 points.
Yeah, it's not 10,000. It's
1,000.
1,076. But yep, you were right. That's the end. That's the record. Okay, what's the flat fee or the start? Amani? Yeah, because we've already scored that amount, that's now our starting point to reach that goal of 1,076. Now, this part's a little confusing. What's the rate in this case? What's the rate? Alexis? It is 10. And it's not really a rate, but it is the number that we're going to end up multiplying by. In actuality, the rate is the piece that's missing, and this is the number of times that we're going to multiply it. So it's flip-flopped, but it still serves the same purpose. We're already told what's missing. P is missing, the number of points scored per game. So in the past, we've written this. We take the total and put it all the way to the right, and then we put an equal sign, and then we fill in the left. So let's do that, and then we'll change the equal sign afterwards, or figure out what goes here afterwards. What's going to go on the left-hand side? You should have an instinct about this at this point. You've done it a lot of times. Excuse me. Alexis? Good. 736 is going to go over here. What else is going to go on the left-hand side? Kiara? 10. So it's just going to be 10 and 736? Well, remember that the rate and the missing usually go together. And now what's going to happen with these two terms? Are they going to be added, subtracted, multiplied, divided? What do you think, David?
Well, first what you do is you take
No, I'm just asking. Listen to my question. What's going to happen to these two terms? Are they going to be added, subtracted, multiplied, or divided? Divided, so you think I should put a division symbol here? Okay. So the problem is you went beyond where I was and you tried to figure something out, but yet you weren't even ready for it. Fancy? Yeah, we're going to add it. Because think about what you're doing. You're taking, what happened to my, I went too far. We have 736 points, and then we're going to score some points over the next 10 games. We're going to add those on, and then we're going to try and get more than 1,076. And that's where the idea of an inequality comes in, because we are not trying to equal, we are trying to break the record. So what symbol should go here to indicate that we're going to break the record? What symbol has to go there? We got a lot of anxious people who think they know. What do you think, Chelsea? What do you think, Annie?
Greater than.
Okay, so that's a disagreement. Stephen?
Greater than.
Okay, so you agree with Chelsea. Kiara?
Greater
You agree with Annie? What do you think, Savannah?
Greater than or equal to.
Or equal to? Okay. Angela? Greater than? You said it very casually. Could you explain?
Oh, because you're, the record is, you're trying to beat the record, which is 1,076 points, so to beat it, you would want more than it.
Yeah, that was a great explanation. I hope their classmates were actually listening, because that was a perfect explanation. So, the symbol that must go here is this symbol. Can't be or equal to, because or equal to would not be breaking the record. That would be equaling the record. We want to break the record. So now we have an inequality to solve. When we solve the inequality, then we can figure out or the average number of points we need to score per game to actually break the record, and so you can set a goal for yourself. So the rest should be pretty basic for you guys because this is a two-step inequality. There's nothing to simplify. We just draw our t. And what's the first step in solving? David?
Well, the first thing you do is subtract 736 from both sides.
Yep. Subtract 736 from both sides. This will disappear. We still have the 10p left over. Is greater than. And now what do we get as a result of that subtraction? We got it, did already, 340. And now what's the final step to solve the inequality? George?
Divide both sides by 10.
Divide both sides by 10. This will cancel, and we are left with p is greater than what? Tatiana? 34. But now we need to check if we were supposed to flip the symbol. Give me a thumbs up if you think we're supposed to flip the symbol. Good. Tristan, how come?
Well, because you divide this,
Good. We divided. Excellent. Did we divide by a negative number? We divided by a positive number. Yeah, we only flip the symbol if we divide by a negative number. So no, we do not flip the symbol. The symbol stays the same. So what that means is, for the last 10 games of the season, the team has to get at least an average of 34 points per game, and then they will break the record. So they have to get more than 34 points per game. Okay? Very good. I have to completely modify, so classwork is going to be skipped. And so everyone draw a line across their paper. You'll get a free point for classwork. And your homework is page 153, numbers 10 through 22 even, and 42 to 48 even. That's 11 questions. And you are going to have a test on chapter 3 on Thursday.